Greetings, fellow mathematicians. We're going to take a look at our second problem of finding a derivative by using the limit definition. And like the first problem, we're going to go through applying both equivalent versions of the limit definition of the derivative. Now, if you're not comfortable or sure of these steps, or you want some tips for going through these steps, check out the video I have linked down below in the description where we'll go over that in detail. So we're going to pick up with the first step. We're going to replace a with 3 and calculate f of 3 plus h and f of 3. All right, so for the problem, we're given a as 3. And we're going to calculate these two function values. Let's do the easy one first, plugging 3 in to our function. We're just going to replace x with 3. And we'll get 3 squared plus 4. 3 squared is 9, so this should come out to 13. All right, all the work for this problem is going to occur in calculating f of 3 plus h and simplifying it. So let's go ahead and replace x with 3 plus h. We'll get 3 plus h squared plus 4. And it's at this point that a very common mistake is made by many students in calculus courses. It's incorrectly multiplying out or expanding 3 plus h squared. So let's mention what that mistake is. And it's taking 3 plus h squared and thinking that it's going to be 3 squared plus h squared. And that is not true. What's missing is the terms for the outers and inners, which would give 6h here. So correctly FOIL or expand that, and you'll get a missing 6h term. All right, now once we're aware of that, let's go ahead and correctly multiply that out. You do get 3 squared, 9, plus 6h, plus h squared. Those are the terms from 3 plus h squared, but we also have the plus 4. All right, and always check to see if there's any like terms that you can combine together. It looks like we have the numbers or constants 9 and 4, which you can combine as 13. So let's write this as h squared plus 6h plus 13. And that's it for step 1. Now we're going to go to step 2, taking the difference and subtracting those two function values. So we're going to take f of 3 plus h and subtract f of 3. A tip that we mentioned in the video linked down below is to use parentheses, but here what we're subtracting, f of 3, is positive. So here, the parentheses won't make a difference, since we're not subtracting a negative. So let's take all the terms from f of 3 plus h, which are h squared, plus 6h, plus 13, and we're going to subtract the value for f of 3, which we found was 13. All right, and again, there should be a lot of terms that cancel out here. For this one, it's just the 13s that we can cancel out. They'll combine to 0, and we're left with h squared plus 6h. Now there's a nice check that we'll mention here. Once you go through and calculate this difference, you should find all the terms that remain contain a factor of h. So let's write the check as all remaining terms should contain h. And here they do. We have h squared. That has a factor of h in it. And 6h, that also has a factor of h. The reason why you want all terms to contain a factor of h is for step 3, where you divide by h. Now let's make that easy here. Since every term has a factor of h in it, let's go ahead and factor h out. And we'll write that as h and then times h plus 6. And that's as far as we can take step 2. Now we're going to go to step 3, dividing by h, and the h that we factored out, that will cancel. But let's write it all down. So we're going to take the numerator, which is this difference, and that is going to be divided by h. So we just simplified in the step above. We got the numerator, the difference, as h times h plus 6, and now we're dividing by h. And you can see those factors of h will cancel, and we're left with h plus 6. And this is the quantity or expression that we're going to be taking the limit of as h goes to 0. So we're pretty much done almost all the work here. The last part is we're just going to calculate f prime of a, f prime of 3. This is what we call the derivative, which represents the slope of the tangent line. We just now take this result and take a limit as h goes to 0. So we're taking the limit as h goes to 0 of h plus 6. And at this step, where the factors of h cancel, that's where the indeterminate form will cancel out. And we get here a limit with no indeterminate form, so you can just go ahead and plug in h equal to 0. And what you'll get when you do that is 6. And that is what we call the derivative of this function at 3, but this value 6, that represents the slope of the tangent line. All right, now we can move on to part B, which is finding the equation for the tangent line. And always keep in mind a basic form for the equation of a line. Point slope form here, y minus y1 equals m times x minus x1. We're now just writing that, the y values, as a function value, f of a, and the slope as now f prime of a. Fundamental idea in Calculus 1, we calculate slopes of a tangent line by calculating a derivative. And right now, we're calculating a derivative using the limit definition. Coming up in your Calc 1 course will be some rules and shortcuts for calculating derivatives. But you're not there yet. All right, now let's go ahead and take the result here, f prime of 3, which comes out to 6. That represents the slope of the tangent line. And let's just go ahead and write it down. The equation of the tangent line, I'm going to write it in this version with a as 3. So we have y minus f of 3 equals f prime of 3 times x minus a, x minus 3. And now we just need to plug everything in. We already found in the beginning f of 3. That comes out to 13. And we just calculated, using the limit definition, f prime of 3. That came out to 6. All right, so if we just rewrite that, we get the equation for our tangent line as y minus 13 equals 6 times x minus 3. And that's it for a complete part A and B, where all the work for part A, in using this version for the limit definition of the derivative, almost all the work was just in expanding 3 plus h squared, which really isn't that bad. Next up, let's go ahead and calculate the derivative using the second equivalent version for the limit definition of the derivative. Next up, with the second version, we're going to find most of the work instead of expanding 3 plus h squared, we end up with having to factor some sort of quadratic polynomial. So let's start with the first step, find f of 3, which we already did. We can now move to the difference, f of x minus f of a, f of x minus f of 3. All right, so we take the entire original function, x squared plus 4, and we subtract now f of 3, which we found was 13. All right, and we can simplify that. 4 minus 13, that's negative 9. And again, the work here is going to be factoring this, because again, step 3, we're going to be dividing by x minus 3. The indeterminate form should cancel. Now, this one might seem easier and faster, since this is pretty easy to factor, since it's a difference of squares. You've probably factored this like 1,000 times already. That will factor as x plus 3 times x minus 3. For some other problems, this might be a lot more complicated to factor, but with the first version, it might be very straightforward but tedious to multiply and expand. So just be aware of that. Some of your work with the first version is tedious but straightforward, like multiplying out and expanding. Some of the work here could be shorter if you're on top of your factoring methods. And I find a lot of students have difficulty factoring, so just go ahead and if you want one definition to apply, apply the first one here. You're going to typically avoid a lot of difficult factoring problems. Here, that factorization is simple. All right, now we can move to step 3, which is dividing by x minus 3. So we take all that stuff, f of x minus f of 3, and we divide by x minus 3. All right, now we already simplified that. The numerator, we factor that as x plus 3 times x minus 3. And now you can see in this step, the terms that give you the indeterminate form, 0 over 0, they cancel out. And what we're left with is x plus 3. Our final step with this second version for the limit definition of the derivative, we now take a limit as x approaches 3. And this gives us the derivative, the slope of the tangent line, but now we're taking a limit as x approaches 3. And x is approaching 3 in this expression that we just simplified in the step above, in step 3. All right, and since right above the indeterminate form canceled out, you can typically evaluate these limits by plugging in here x equal to 3. Since x is approaching 3. And if you do that, looks like you're going to get, again, 6. And there we go. Now for this one, I can't say it's any easier or harder than the work when we applied in the first part, the first version for the limit definition of the derivative, but the work is different. Here it came down to factoring, and that's pretty simple since it's usually easy to factor a difference of squares. But in the first part, applying the first version, we had expanding the term 3 plus h squared. Both should be very straightforward for you, and make sure as you go through problems, you try to practice both of them. Hope you enjoyed the video. If you did, support the channel, like and subscribe.